Hi, and welcome to Introductory to Physics class. I'm your teacher, Mr. Boss, and I will help you understand and maybe comprehend and maybe apply physics and what we do in everyday life that surrounds us with physics. I can't wait to get into this. Our first lecture is going to be kind of on the history and kind of the developments of where physics became and kind of go from there. Our textbook that we're going to use is mostly this book, Conceptual Physics, 10th edition. There is more newer editions, but we're not going to get into that. And this is by Paul Hewitt, which is a very interesting physics teacher. I think he's a physics teacher. He's written a couple books, but this is pretty much the one that we're going to be focusing on the more. Are we going to go through the whole section of the book? Probably not, because there's a lot more than here than we can chew. But maybe I can try to extend this because this is, being recorded. But anyway, hopefully that you're ready to do this. Again, I'm your teacher, Mr. Boss. Mr. B's fine. And let's go through this, all right? So hopefully that you're ready. I'm excited about it too because we get to go through, kind of what physics is really about and how it arrived. So let's get to it, all right? All right. Okay, so we're going to get through the preliminaries here. This is kind of like the introduction to, the history of stuff like that. But why don't we go ahead and go through what is physics? So physics, it was derived from the Greek word, physis, which means nature. So the study of nature, the study of the phenomenon, pretty much of the world. And the purpose was we want to ask these important questions. We want to ask why. We kind of want to be curious, having that curiosity, because curiosity is always good, and being that creative thinking really does apply to it as well. And really, we want to seek and explain kind of like the relationship between how energy and matter and what they do together. The whole world, what we have in our bodies, what we have on Earth, what we have in the universe, we're going to talk about this later, like the Big Bang. It has so much energy, and everything is composed of energy. And if you kind of take that energy away, it actually doesn't go away. It just transfers to something else. We're going to talk about that much later on. But it's that relationship between energy and matter. And we will talk about those concepts later. And what physics is all about, it's really just the root of all the other sciences. So we have, chemistry, we have, the kind of study of molecules and the cellular level, and then biology is kind of like, bio means the living aspect of it, and kind of how things store their energy with the mitochondria, the powerhouse of the cells. And you have plant cells, you have animal cells, and you kind of have these different ways of understanding what the energy of the cell is doing in the nucleus. Part of it, you have astronomy, and astronomy is kind of the idea is like, you want to look at the stars. We want to see what is going on out there in kind of the heavens. This is kind of what the Greeks were, or early explorers were thinking about. Kind of what is going on out there. Are we stuck on this little teeny rock? Is it very small? We don't know the size of it. And that's kind of what's going on with that. And then, actually computer science, if it wasn't for physics, we wouldn't have a really in-depth knowledge about semiconductors, and the theory of, small microchips. And that's really understanding. I mean, we have these little boards that look like these little circuit breakers with these, resistors. And we really need those, kind of the resistors look like this, and capacitors, and we kind of need that to understand our computer that you're watching, or your device that you're watching this right now on. So that's kind of like the breakdown of what physics is. It's really just how it's the study of nature and how it works, and relationship between energy and matter. Okay, let's go through some history of kind of the development of kind of where physics became about, kind of where the thinking was. And so, history and beyond of physics. So, back long time ago, um, Thales of Miles, about 1624 BC, before Christ, and the development of math was coming about. Logic was kind of thinking about it. It was, we had to divide cattle raising, land use, and we kind of wanted to know, if I have like a bull or something like that, a bull, what does that mean? Actually, that's a number. It means zero. And then you kind of go through the list. You might have pebbles, and then you might have little small rocks. They might mean one. So if I said, okay, if I have these five X's, well, now we have a number that says those are a group of five. And then the Roman numerals, which we use, and we have one, we have two, we have three, and we have five, and then 10, I do believe. And then we have, I think that's 50. Well, those were coming about too in the Roman numerals. But think about this: there's no zero there, so the Roman numerals don't have a zero. So technically, there wasn't a year zero. But we're going to talk about that. I'm jumping the gun here because I'm kind of excited here. But going back to Thales, he was, a Greek mathematician and philosopher. He really wanted to know kind of, how does the world work? And he was kind of what we call a scientist. A scientist is somebody that studies, maybe data and explores their curiosity of understanding the world and how things apply. And he kind of was looking at the cause, what causes things to happen in the world, and kind of using that deductive reasoning, if you want to call it that. It was called that, but much later. But that kind of that open mind of what's going on in the world, and that was the kind of the first person to kind of use, that maybe logic. Logic is very different than a lot of people. It's everybody has their different kind of logic, but we kind of now agree on things to a certain extent. So now the next thing, Pythagoras, Pythagorean identity, Pythagorean theorem. We don't know if he really proved it or not, but he was a mathematician in Greece and Greece and Italy, about 1940, 1490 BC, and he built a school of logic, and it was mostly male dominance that could enter the school. And I know I don't want to get all gender and sexist all there. So I hopefully I can't change the history here, but that's kind of what opened the door to more of this. Hey, taking Thay's kind of thinking and apply it, say, kind of to the Pythagoras' his world. And there's a lot more we could talk about here, but I don't want to have the time to do that. Then after that, a lot of good stuff opened up here. Then a fellow called Plato came about, and he opened the world of geometric solids. And there's a lot more here that we can talk about with Plato and Plato's Republic. This is a book that you can talk about. But this was back in the Greece and Athens, believe it or not. And he was a student of Socrates, which, if you don't know who Socrates was, he was also the more enlightenment thinking, study of the soul, God and all that good stuff, and trying to kind of determine what we're doing on Earth here. But Plato, he had what these call these geometric solids, and he had pictures of these, and you can actually look these up if you want. They're called oh my God, I'll think about it in a minute. But these, he had something that represents fire, air, water, earth, and then the Athens, which is kind of like the heavens, which is like the earth, the Platonic solids. Thank you. But the Platonic solids. You can look that up if you want. And kind of has these little different arrangements, and really they're kind of like in a ball shape, but they were kind of something like this, and they all mean something for fire and air, and they're kind of like a little, I would say, like pyramid shape kind of thing. So if you kind of take like a pyramid like this, or a string, or a triangle, and then reverse it, you kind of have something like that. So that's kind of what happened with Plato. I mean, he kind of opened this door to thinking about a little bit more about the world and how the world was kind of coming about. All right, now you got this lovely person. I guess he was lovely. I don't know. About 300 BC, called Euclid, and he opened the door to our geometry, our modern day geometry that we use in schools today. It's called the Euclidean geometry. Most of this was like 2D, geometry that we use today. And he wrote a book called The Elements. If you want to put that down, you can. It's not really that. It was pretty much the most second read book besides the Bible. And it really turned out to be like, this is kind of where you start. A couple things is that on the thing is you have, okay, a couple things is I have a point that has no depth and no direction. It's just a point. Well, what if I took that point and draw another point, and then I had what we call an endpoint? Or maybe we can extend that to a line. A line is an endless, in this way. Well, what if we take this idea and now take this, put a point, and then now rotate it? It's a terrible circle. And then rotate it around. Well, what do you have? You have a circle. And this is kind of where the theory with circles came about, and a lot of our basic geometry. And if you want to look this up, he had what we call the fifth postulate. And the fifth parallel postulate says that if I have a parallel lines and I cut by a transversal, how do I know that these are parallel? And that was a big discovery for many years until Gauss came up with, we have different geometries to look at this. So you can explore that a little bit much if you want. So we have Euclid that kind of has, the kind of like the door. All right. So now, moving on here, what gets more exciting is that you have another thing called, Aristotle. And Aristotle kind of really opened up the door for, more of the science aspect. And, he kind of showed, and I don't know if he really proved a lot, but this is kind of where a lot of our logic comes from today. And a lot of the stuff that he did was kind of proved wrong, but he kind of got us on a start to kind of think about what's going on. And so this kind of like the start of science. And he actually trained, he was actually the tutor. If you want to look this up, you can. He was actually the tutor of a famous general that almost took over the world. And if you don't know who that is, guess who it is? My mind just went. It'll come to me in a minute. Yes, you can look that up. He was a tutor of a Roman. He was a kid. I forgot his name, but that's okay. Oh wait, Alexander the Great. There you go, Alexander the Great. You can look that up. And he pretty much almost ruled the whole entire world, and then he was killed by his own people. You can look that part up too if you want. But anyway, enough on that. Let's go through Aristotle now. He kind of studied the logic, the introduction tools of the deduction, and that he said that the purpose that heavier objects fall faster than lighter objects. So if you take a feather and a ball and you drop them, you took a ball and then you took a feather and then you dropped them. Well, obviously this ball is going to drop faster than the feather. But what if I took a small ball and a bigger ball and then dropped them? His deduction would say, well, this has to fall faster. And that was proven wrong by Galileo. And we'll get to that in a little bit. But his ideas really opened up this new paradigm. So if you want to look up a paradigm of thinking. says that, okay, we have this geocentric theory that, the Earth is really the most fundamental element that we have. It's what we're on right now. It has to be the most important. So we're going to say that the Earth is the center, and everything else revolves around the Earth. The sun and all the other, I think, four planets were known at this point, if I'm mistaken. Four planets. And so, Mercury, Venus, Earth, and Mars. So, and I think the other planets were seen later with Galileo. But we have these planets running around, and he says, okay, well, our Earth has to be the center. And that's period, because it's really need to focus on the Earth here. And there's a lot more into that if you want to go, this approach to this theory. But he did believe that we have these fundamental theorems, fundamental elements on Earth that we believe, and that this is what's called the geocentric theory. Geo means Earth. So going from there, you have this person called Archimedes. Archimedes, he was a fantastic inventor, mathematician, scientist, you can call him that. He a lot more inventor, and he kind of opened up the door to, enlightenment of other things here too, inventions. He was born in Syracuse, which is an island off of Italy. He helped fight against the Romans, and the Roman Empire were kind of going around, and they were in charge. And he was trying to fight against them, and this is kind of might be a myth or some kind of just it's some objective thinking, but he said it's said that he built these mirrors. These mirrors look like this. They're like concave mirrors, and there was some ships right here. And what happens is that you take the sun, and the sun's rays would bounce off the ships and then set the ships on fire. That's kind of what he invented, or maybe invented, that this part that he made these mirrors that transform the energy from the sun into burning rays of fire. And that's kind of what you do with a magnifying glass, if you think about it. But he fought against the Romans as much as he possibly can. He found the number of pi to pretty much is what it is today, and he was doing all this, at the time of a change in the world, and he kind of discovered buoyancy. So if you have a little bit of water and you have a ship that floats here, you have it displaces a lot. This is called buoyancy. Oh boy, let's see the name. I do believe it's like buoyancy. That's pretty much. And that kind of developed is that he developed a thing called the Archimedes screw, which kind of says if I have some water down here and I have a cliff here, this will kind of carry water up on the land. That was a big invention of him. Another thing, he did the catapult. So if you have a catapult, you have some stuff there and goes like this, it launches up in the air. Big thing. And so you can kind of look more about this, but I'm not going to go into more. But anyway, he discovered kind of a lever, and he says that if you want to move something like the Earth, give me a long enough lever to stand on to move the Earth. So that's a big thing you want to kind of look at. Kind of a lever looks like this, and then if you put the world right there and you stand somewhere, you can kind of move this. This is like this the length of this. Of the lever there. More on that. Now you kind of go to this person called Ptolemy, and Ptolemy, he about it's about 85 to 165, like the turn of the century there, and he took he was an astronomer, and he kind of took Aristotle's kind of his logic and says, okay, the church was kind of the ideal spot here. And they're kind of in charge. The Bible was the most. After this, the Bible was kind of in place, and people wanted some more earth thinking. And Aristotle's ideas kind of made this new paradigm of thinking. And so Ptolemy was interesting person. He created a planetary system that had something like the Earth that was at the center, and he kind of made this little system. Said, "Okay, I have the Earth here, and then these are kind of going around this object." And so you can kind of almost see that it's very similar to what we have today. There are just some few modifications that we're going to make later on. And this is just something interesting because now we have a model of what we see maybe in the earth or outside in the heavens. We have this geocentric, which remember, geocentric means that we have the earth center. And it just made a lot of assumptions. And he had some important points that what we use today. So he wasn't all wrong. There's more to that. Now, the Dark Ages kind of were just going on. Dark Ages really were nothing was happening. No enlightenments were kind of developing. It was pretty much Roman empires been kind of seized, and it was kind of going through changes here. And then you have the gladiators fighting. There was anarchy. Well, anarchy. There was just nothing happening in the world on the earth. There was little things, but they weren't really developed. And you can look into that more if you want to, but I'm not going to spend a lot of time on that. But that lasted for about 1,500 years. Well, and then something happened, kind of an explosion of scientific enlightenment, math enlightenment thought. It was the Renaissance. And the Renaissance kind of opened the door to the rebirth of classical art, literature, and mathematics and science, what we call science. And it was this new paradigm of thinking. It was this, in Italy, they originated in Italy, and it was just this rebirth that fostered this new world of inventions and conceptions, kind of challenging what our views are today. Remember this: the Roman Church, the Vatican, was pretty much in charge of all of our scientific information, our knowledge that we have. And it was really hard to kind of go against something like that because you have to it's like almost like stepping on eggshells. And so Nicholas Copernicus, he was a Polish astronomer. He worked for the church. He was Polish astronomer, and he was working, kind of like church. But his kind of like his night job or his side job or something like that, you want to call it, his hobby was really astronomy. And he wanted to look in the world, and he kind of was looking at, he was in his room and he had a window here, and at night the moon would be here, and then the moon would kind of shine through his window at different spots. And he was thinking, that's very interesting. And then maybe when kind of also the sun was kind of doing the same thing too. And there's a lot more to this. You want to kind of go through this, but he kind of got this idea of, hey, I got this data, but I really think that Aristotle is not correct here. That it is not the geocentric theory, and Ptolemy's theory was actually almost there, but there's a few things I want to change. And his clues were that, hey, it's the sun that's the center, and we revolve around the sun. And that was a big move right there. And it didn't get developed for about 100 or some odd years. So this is called the halocentric view, or sun. And it's very interesting, as this kind of was a big controversy here, because we have to be careful, because if we go, if we think something differently than what we all believe, it was bad. You can be persecuted back then. And so Tycho Brahe, I think that's how you say it. He, after Copernicus died, all of his data was given, And Tycho Brahe, he gathered Copernicus's information, and he was a Danish astronomer, Danish astronomer there. And he kind of really believed in what he was studying. He wanted to study the stars too, and he did a lot of observations on his own, and he did a lot of discovery himself. And he never really accepted Copernicus's gatherings, his model of the world, because Copernicus actually made the same model as Polymorph, but he called it the sun centered. And that was a lot. That was like it just made a lot of his data kind of almost on that right track. So Tycho Brahe was on the verge of on his deathbed. He was dying of something, I forgot. And a lot of his observations he gave to a fellow called Johannes Kepler. So Tycho Brahe gave a lot of his information to Johannes Kepler, which Kepler was, he was a German astronomer. You can kind of see how this is all moving all everywhere. And he was a German astronomer, and he accepted what Copernicus was talking about because he was believing all this. He says, that this model, I see evidence of it. I see what's going on. I have my own maybe conclusions, and he came up with the three planetary laws of motion. And we can talk about those later, but it was one of them was that the planets revolve in the shape of an ellipse. So kind of like this, in an elliptical orbit, which as you get farther from the center, they start to kind of do this little oval kind of idea there. And there's a lot more to those three laws. We talk about them later when it's acceptable. But that was a big controversy there because we had to keep this quiet. Remember, we're going against something that was already assumed to be right because we already had it down. And then, famous person. Hope you've all heard about this person, Galileo Galilei. He was an Italian astronomer, about 1864, and he really opened up the new door to this new paradigm of more a way of thinking. He was an Italian, obviously, philosopher and mathematician. He was born in Italy, Pisa, in Italy, and he was called a true Renaissance man. Okay, if you don't know what a Renaissance man kind of a person that kind of does everything, kind of like a person that does everything. You call him kind of a there's a word for that too. My mind's gone on some of this stuff here. A handyman, and he invented this thing called the telescope, which hopefully you all know about the telescope. Kind of does this, and then it has these mirrors in here that it kind of goes in and it kind of hears a signal. The light comes in, it reflects, and it makes things smaller, or sorry, bigger that you can see far away. And he kind of saw the moons of Jupiter. That there's this other planet, there's the other planets out here that has moons. Oh, cool! And we live in this thing called the Milky Way galaxy, the spiral galaxy that kind of looks like this. The spiral galaxy at night, and his career took off from here, and this was just enlightenment thinking. This refracting telescope, he was first to explore friction, the concept of friction and motion, and this is kind of like showing this thing that we have this force called gravity. We didn't really. It was kind of like what we'd say today is gravity, but this thing, something that falls, something that's forcing to make something fall. And he was really the first scientist to explore the nature of friction and the effects of that. But it has something to do with the motion of the object on it. So big stuff there with Galileo. Then you have this person called Rene Descartes. Rene Descartes was all over the place here. And, we kind of get what we call the Cartesian coordinate system, the Cartesian plane. And if you remember in math class, you have what we call a XY plane. we have the Cartesian coordinate system. And this is where we can kind of, monitor points from x, comma, y. And this is kind of where the 2D aspect of this and the two-dimensional ideas are common. Well, now you kind of have these scientists that open up the door. Now we have to have all this information make sense. So we have this thing called the scientific method. And this is about the 1610. And there's more on this. You can look this stuff up if you want. I'm not going to stress this much here. But we have to have some common ground now because we have all these experiments going on. So the scientific method really was a process for science and its understanding. We got to make us all kind of have evidence. We really want to look for this thing called evidence because we're doing too much now. We want to see the proof in the pudding. And so we have to have a process that we all agree on. And so you want to kind of make an observation. You kind of want to make a hypothesis, what's going to happen. And you want to have a way of testing that and experimentation, getting the data. And then you're kind of have results. What is testing the data? What does the results say? And then it kind of, this is actually very movable. So there's things that you can actually add, but this is kind of like the process that you have to agree. And I know there's a couple more things like if your results don't verify your hypothesis, you have to go back to your hypothesis and retest or something like that. But I'm not going to talk about the scientific method too much more after that. So now you have what we call this new paradigm of modern physics being born. So you can see that there's a lot that happened here. It kind of gave a catalyst into what we are doing today. Okay? So, well, now opens up the thing about Isaac Newton. Now, a lot of people might not like this thing that I'm about to say, but Isaac Newton wasn't really a famous mathematician. He was pretty much a famous scientist, but he did do things with math, believe it or not. But Isaac Newton, about 1642, about the 1600s, and I think he died around 1727, I do believe. Anyway, he was an English physicist. And he was pretty much the greatest mind in history, in history of this. He did pretty much everything you can probably make your imagine. Invented something called the calculus. We can talk about in a minute. He developed what we call these three laws of motion. And we can talk about these later, but I will give you one right now. If you take a ball or an object and you just let it sit there, it's not going to move at all, right? There's no motion. You have you have gravity and you have what you call a normal force. But every other forces there's no acting on it, right? Well, what happens is that if I gave this thing a force in this direction, well, you know darn well that it's going to move this way. Where's it going to move? Well, it's going to move on forever. But in real life, the practical, we know it's going to slow down because of friction. So it's called the law of inertia, right? And if you push an object, it goes on forever. And we can go through those later. I think it's called a body at rest remains at rest, and a body in motion remains in motion. I do believe that's what it is, yes. And then there's two other laws that we were talking about. But he came up with the law of gravitation, that we have some kind of, we have this kind of G. I do believe that he actually didn't think about this G. It actually came a couple years earlier, but we might have to go more into that. I'm not going to talk too much about this. But then he kind of had this formula that we will discuss later in the class here, that if you take some force times the constant of G, and you have a mass of an object times another mass of another object, and you're doing their distance squared, you have what we call an attraction of force. So this object and this object has a force of attraction. We're going to talk about that much later. But just think about that formula. Oh my boy. He did something with what we call light. So if you take if you have a window here and you have the sun, and you have these lights and you have a prism and it goes to light and it kind of shows, I think it's Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. It shows the spectrum of light put through it. So all white light has the colors of the rainbow. He opened up the door through calculus. He was a co-creator of calculus. There's another person. He was a German mathematician, Gottfried Leibniz. I hope I can spell his name. Leibniz. I think that's how you say it. That might be a B. I think that's right. Leibniz. But you can look that up if you want. So he gave us calculus and stuff like that. It was fantastic. Well, now things are going to change a little bit. Albert Einstein, if you don't know about him, he had the crazy hairdo and stuff like that. He kind of gave us, the space and time relationship that, we have this thing, we have things. Let me show you. So we have these coordinate system in space and time. And if you have a object, what happens to the object? Well, it curves like this, right? And if you put like a little object, it goes around, but it doesn't intersect the object in the middle. It kind of does this thing here. It bends. And so this curved space, you can kind of think this curved space. And he was actually Jewish born. This was back where we are getting to another important conflict in the world. We'll talk about that in a little bit. He came up with the idea of this equation that we see pretty much on TV shows called energy equals mass times speed of light squared. That an object, an element, or in this case, an atom, has this what we call empty space. It has empty space. And there's something in that has energy. And if you mess an atom up, what happens to the atom? Well, there's different kinds of atoms that emit radioactive. And if you put more into the nucleus, it becomes unstable. And so it explodes. We'll talk about that later. He opened the door to quantum mechanics, which is something that was big back in the space area. So World War II happened now. Now, at this, World War I did happen, but there was some science and stuff to it, but a lot of it wasn't into science there. But World War II really opened up the door for science exploration. And here's what I mean. I know a lot of people died. I think 6 million Jews died in the concentration camps. And I know there was a lot of bad stuff happening here and people were going to war and dying. But between these times here, I think the U.S. with Pearl Harbor, 1941, we got started. And this is when the Japanese attacked Pearl Harbor, the ships, and killed a lot of our people. And then I think about 1945 is where it ended. I think it was in April. Don't get me wrong. I think it was about April. That's when we dropped some bombs on Japan, right? And so that really opened up the door to a lot of good stuff. And the Manhattan Project was one of the things that the Americans were working on because we wanted to end the war somehow. Well, yeah, but we were working on the atomic bomb. And, it was centered in, New Mexico, Santa Fe. If you go to Los Alamos, I think it was Los Alamos, if you've ever been there, the United States, let's see, we have California, you got Arizona, you got New Mexico, and I think it's about right there on the tippy top. And there's Nevada. And then I think that's Utah, I do believe. Utah? Yeah, I think that's right. So Los Alamos is right there. I think, the Four Corners is right there. So So New Mexico, so Alamos, Los Alamos was in the production of what we call a Manhattan Project, and it was just in like it was kind of the development of the two bombs that were dropped on Nagasaki and Nagasaki back in 1945 in Japan. It was called the Fat Man and Little Boy, and these are the names given to two bombs. And so that really from Einstein's information about um, not cells, atoms have, if you change the atom atomic structure, they come interactive. And then I know that there's other scientists here that I'm trying to give credit to. I don't want to go too much into this because I'm already past our time here. Marie Curie was one of them. Bohr was another one. I think that's how I said it. There's more to that. There's a movie called Oppenheimer. He was in on this too. So don't there's too much into this for our time. Well, after all that got started there, well, we had the Cold War. And Cold War really didn't have it wasn't really a war that happened. It was nothing happened really. It never got started because Russia in the America SSR, they were going through this until about 1989 when the uh, Gorbachev, the wall came down between in Germany. Remember, in Germany we had the north and the south wall, and Gorbachev was in charge of this, and he took down the wall between the Russia. But there's a history lesson there, and so we were starting nuclear weapons. We had nuclear weapons on both sides because this was the new technology now. And between Russia and Russia was developing, we were developing nuclear weapons like crazy, and they told each other that if we fired them to you, and we will retaliate to you guys. So if the Russians were to fire to the Americas, and the Americas was to fire to Russia, they would pretty much cancel each other out. And so at the time, Russia was doing this heavy money. They had money problems, and they pretty much spent all their money, and they pretty much bankruptcy their entire country. And so nothing really happened at this point, but there's nuclear weapons there. Well, at about the middle of this time, we remember Russia was trying to compete. Russia was competing with the Americas, and they launched Sputnik. And Sputnik was 1, 2, and 3. So it was called the space race began here. And what I mean by this, the first Sputnik satellite, if you want to look this up, you can. It's not a very big satellite. It wasn't that really big. I think that's kind of what it looked like. And it wasn't that very big. It was probably like a room-sized satellite that was launched up into the orbit, the lower orbit, I do believe. And it was a space satellite. A lot of people thought it was a spying satellite. They were kind of looking over our army bases, spying on its people, and it raised a lot of controversy. But people were scared during this time. People don't know what was going on, and they saw this thing. They can see this thing at night. By the way, if you go into an area where there's no lights, and you can actually see the thing orbiting around, and people were just scared. And so I think it was launched on I think it was October 4th. I think it was 1957, I do believe. It was launched then. There's a movie after this called October Sky. You might want to watch that movie. I show that to you guys and my students all the time on this because it really opened up the space race between us. The second Sputnik was, let's just launch a dog into space and see what happens. They're trying to get more things into space. And then I think the third one was just to study the Earth and how the Earth was forming and all that good stuff. So deep stuff. Well, what happened in that realm, after that, this was 57. So America says, what, we're not going to take this. So we have what we call the National Aeronautics Space Administration, which is called NASA. And I think it was Dwight D. Eisenhower that kind of made this happen. In Washington, D.C., says, we got to have some kind of program that we got to get ourselves up into space somehow. and it was big. We have NASA astronauts right now, and now we have SpaceX, and I think Horizon, and Jeff Bezos, Blue, I think it was. Anyway, so we're kind of now looking at the world, but I think it's SpaceX mostly. But the mission was, now after that, we got to beat the Russians somehow. We got to make us known, because the Russians already made they already got into space. We got to go to the moon. So they had the Apollo missions, and I believe there was 11, 12, 13 through 17, I do believe. Apollo missions. There's a lot of Apollo missions, and a lot of them were just, hey, rotate around the Earth, and that was a big thing. And there was, I think there was it's called a movie called Apollo 11 that had some issues too. I think it was with Kevin Bacon, and oh boy, it's been a long time since I saw that movie, but you can look that up. So, a couple things more here, and then we are done. um, that kind of opened up the new developments into physics now. We want to go to Mars. We have SpaceX to help us, kind of land people on the moon and go to Mars. We want to study climate change, because climate change is, if you believe it or not, it's something's happening with the world. The Earth is getting older, and we don't have another Earth to look at. So we got to look at some changes. We looked at particle physics. Things from this point to this part. We have, I think they're called the particle accelerator. Goes like this, and they launched a particle, and I think it was called the God particle. This new big, like how the Big Bang got started. It's called like a particle accelerator. I think this is CERN. Yeah, I think it's CERN. I forgot the acronym, but anyway, this is in Sweden, I do believe. And then we have nuclear fusion, fission. We have lasers now. It's just interesting. We have, our astrophysicists are studying how the world is forming and what's going on. We have quantum stimulation of molecules, and it's just no end to it now. It really opened up the doors to all this. So a lot of stuff here. So you can see that there's so much history that we can talk about, and there is things that we are missing, but it's just too much. And this is only the preliminaries of kind of where physics is beginning to show, and how kind of it's interwoven into our history that we are talking about through the class. So that was a lot to handle, but it's good to have that historical background a little bit, because it's kind of nice to see where things are kind of, where they went and where they're going, and hopefully where the future holds for a lot of this stuff. And so hopefully you rewatch this again, and I hope you learn maybe a lot of aspects of this. Don't learn everything from it, but there's just so much, and I just don't want to focus on too much. But a lot of the people that we talked about, we will dive more into them to kind of see what they are actually aiming for. But now you kind of been exposed to it, and a little bit more, just on the surface level, so you kind of see where they're at in history. So hopefully that helps, and I'm hoping that you will enjoy the class. All right. Thank you very much. I'm Mr. Boss.